Okay, good afternoon, everyone. Welcome to the Mind Action Series Mathematics webinar on probability for grade 11 educators. My name is Rizal. I'm the sales manager at All Copy Publishers, and so I'll be introducing our presenter shortly. Please just also take note that we will, on the 24th of July, have a webinar on the counting principle for grade 12 educators. And the link to register will be sent out tomorrow. We will also be recording this webinar, and we will share the link with all who have registered afterwards. So if you struggle to join, or if anything happens and you have to leave earlier, we are recording and we will share the link afterwards. Also, if you want to ask a question, please raise the hand in the chat, or just type your question in the chat and I will read that to Jurg. I will try and open your mic to ask your question, but sometimes we struggle to get the mic open. So then, yeah, please just type your question in the chat and we will ask Jurg I will read the question to Jurg and he will answer. Also, please note that Jurg will take a quick break at 4 o'clock just to stretch his legs. And you're welcome also to do a quick leg stretch, but that'll be a quick break and then we're back on just after 4. Yeah, and then welcome Jurg, our presenter for today. Jurg is the co-author of our Mind Action Series Mathematics textbooks, and he will be presenting. So Jurg, thank you. Over to you.
Thank you very much, Rizal. Good afternoon, everyone. Once again, it's quite exciting to be with you, even it is only online, but always better than nothing. Our discussion for today is probability, particularly for the grade 11s. And I took the preparation that you also received. I took from our new grade 11 Mind Action Series textbook. For those of you who don't know, we still have our first edition textbooks for grade 10, 11, 12. But we also have a new range 10, 11, 12. If you are interested in them, you guys can speak to Rizal. These notes that you received, they from the new grade 11 textbook. I took out some of the things which I regarded as, for this discussion, not so important, just to make sure that we finish this within the 2 hours. Not to go over time. So on this very first page, if you will notice, there's only some information given. All I want to say is it's quite important but the kids start with this in grade 10, but also in grade 11 to make sure that they know all the terminology. So when we talk about outcomes and sample space and event, and then also the formula how to find probability. I gave that one in words, as you can see there. I just want to get this one. Year over year, I give it the probability formula in words. I say the probability of any event is the number of outcomes in the event over the number of outcomes in the sample space. So then also in symbols, it is this one. The P of E is equal to the N of E over the N of S. Please make sure your learners are aware that the P is the symbol for probability. And you will notice the N stands for, and you all know in mathematics, we talk about a number. So how many, that's what the N stands for. And the E represents the event, whatever that event is. And the S, of course, the sample space. And then also important, that the probability of an event is always a number in that interval from 0 to 1. It can't be more than 1, it can't be less than 0. So it can be 0, It can be 1 or anything in between. Probability can also be expressed as a common fraction, a decimal fraction, as well as a percentage. Sort of it's not a rule, but what we normally suggest is if in a question they give the information in percentages, my advice always is to change them to decimals or common fractions, do the calculations, and then give the final answer in percentages again. So the way they gave the question, we answer the same way. So that is just this first page. So if I go to the next page, and this is where we start with the rules of probability. Now, in grade 11, you basically need to cover 4 different topics. The first one is this one. It's rules of probability, which we will discuss now. After the rules, we're going to look at Venn diagrams. After Venn diagrams, at two-way tables, and we're going to finish with the tree diagram. So that is what the grade 11 syllabus is all about. So the very first one here, we call it the general rule. This rule is also given on the formula sheet. There aren't many of these rules given. As far as I remember, it's this one. Not any of the other rules that we're still going to discuss are not given on the formula sheet. I recommend that learners must know this formula, and I always say just remember a pattern, just to say that OR is equal to A plus B minus AND. And they can just remember that pattern and they can fill in the events, A and B, X, Y, whatever they called. So this formula, if you think for a moment of a Venn diagram, that's now before I start with that first example, I can maybe just quickly do a little drawing for you. And then we can quickly talk about only this rule. I want to mention something about it. So that's my sample space, and that is A and B. Looks a little bit ugly, but it will do the job. So when we talk about OR, you hopefully all agree with me, OR is, and now let me, this one too, this just doesn't look good. Let me try again. All right, something like that. Not really better. But when I talk about OR, we are referring to this part, everything inside, that is OR. So OR means whatever is in A, whatever is in B, as well as in AND, because that is the intersection is AND. Now to find this OR, you will notice if you look at the rule here, the rule says OR is equal to A plus B. So we take whatever the probability of A is plus the probability of B. Now, if I do this, you will notice that the AND is added twice. So you will see, if I look at A, this thing changed now, sorry. So if I look at A, you will see that the A this thing changed now to the eraser, and I didn't want to erase it. But just give me a minute, then with more practice, I will get better. So what I'm trying to explain is, if you look at A, you will see when I look at A, the AND part is part of it. If I look at B, the AND part is also part of it. So the OR is only the inside. So if I say P of A plus the P of B, you will agree that this part is added twice. It's part of A as well as part of B. And then it makes sense why we do that. We subtract the AND once. and that makes the rule true. So just a little bit of explanation. It works quite well for the learners if they can see it and to understand it, and then it's much easier for them to use. I want us to quickly talk about this first two examples. They're pretty straightforward. They're only basic examples that we start with. You will see in the first one, I say the P of A is given, P of B is given, and is given, and they ask for OR. I always recommend that learners must write down the rule first before they do substitution. So we say it's the P of A plus the P of B minus and. And then it is just a matter of substitution, which is 0.3 plus 0.4 minus 0.1, and that looks like 0.6. We can leave the answer as 0.6. The probabilities were given as decimal, so we leave the answer as a decimal as well. In the second one, I did a similar question. The only difference is I did it as a word problem, because that sometimes is confusing for the learners because they don't always know how to present this as probabilities if it's given in words. You will also notice I gave it in percentages. So I say a restaurant, 40% of customers order a starter, 50% order dessert. 60% of customers order at least one of the two. Now we must think about that one carefully. And then I ask the question, what percentage of customers order both? Now, before we do the question, I just want to highlight something for you. When you notice the word both, it always refers to and, because that is both events. So if you look at this diagram again, that is your and. I don't know why it's doing it. This part is your and. Now, that and means it's part of A, but the and means it's also part of B. It's part of both. So whenever we see both in a word problem, this question, they ask for and of the two events. What was given to us? The probability for a starter and the probability for a dessert. And then you will notice the 60%. The 60% of customers order at least one of the two. Now, at least one of the two is or, because you can just think for a moment, we can say it's A or B or both. That means at least one of the two, but it can be both as well. So we now need to write this in terms of probability, what is given to us. We can decide on the symbols that we would like to use. For a starter, we can use S, and for a dessert, let's use D. So first of all, I'm going to say that the P of S, and this is maybe confusing. I think I must change it, because that S refers to sample space, and it may confuse learners if we talk about the P of S, which maybe we can say is the P of the sample space. So let's say P of a starter is equal to, and that was given to us as 0.4. 40% of customers order a starter. The probability for dessert is 50%, so that is 0.5. And then the probability that then is given to us is probability of dessert is 0.5. And then this one that I referred to earlier, the 60%, that one, that is or. So we say the P of starter or dessert is equal to 0.6. So those are my probabilities. So you can see I've got the probability of the one event as well as the other, and then or is given. the question is to find and. So you will notice it is the opposite of the previous one. The previous one, and was given, and they ask for or. Now, if we quickly look at this rule again, it is something you may suggest to your learners, that you will notice in the rule we've got or on the left-hand side and on the right-hand side. But you notice that the negative is in front of the and. So if I take and to the left and the or to the right, the rule is almost the same, but it's now the P of A and B is equal to the P of A plus the P of B minus the or. So you can tell your learners that they can swap them if they want and, or they can leave it like that and just manipulate it after they substitute it. It all depends what you would like. So let's change it around, and I'm going to say the P of starter and dessert is the P of a starter plus the P of dessert minus the P of starter or dessert. And let's now just substitute. So it's 0,4 plus dessert 0,5 minus the or as 0,6. And I think I've got everything correct here. 40, that is correct. 40 plus 0,9 minus 0,6 is then 0,3. Please take note, the question also said what percentage of customers, so the learners must now write down 30% of customers will order both starter and dessert. I'm pretty sure these are still okay. It's always good with the learners that we start with the easier questions, because that builds a little bit of confidence as well as we go along. And we hope they will cope. So a few more questions on this. I think I just skipped something. Yes. It's again just the following, the next few rules that we have, the mutually exclusive, exhaustive, and complementary. I left the theory in here so that you have it if you want to use it with your learners. So you may hopefully remember that when we talk about two mutually exclusive events, it means there is no intersection, there is no and. So the important thing about mutually exclusive, whenever the questions say the events are mutually exclusive, the learners must write that down immediately, that the probability of and will be 0. So just for the fun, if I sketch this, then what it means is the two events will not intersect one another. So that is how mutually exclusive events will look like. You will see there is no and. So it means our rule now change, not really change, but we can adapt it to this. And you will notice this, that or is now equal to the P of A plus the P of B, because it's minus 0, like I said in the previous step. So that is just to explain the rule on mutual exclusive events. Exhaustive events, sometimes they put that into a question, but it's not very common. But I still think it's important to know exhaustive events are when the two events exhaust all the outcomes. So what it means in terms of a Venn diagram, if I can quickly show you, then it means if I draw A and I draw B, so this one is B and this one is A, you will notice there is my and, because mutual exclusive is not about and, it's about that it is, exhaustive. It's about all the events are exhausted by the two events. So that means there's nothing on the outside here. All the outcomes are inside the two events. And now the important thing here is that or is equal to 1. Because you can think the probability of the sample space is always 1, and therefore the OR will be 1 for the same reason that OR will be the same as the sample space, because there's nothing on the outside. I hope that makes sense to everyone. Then when we get to complementary events, it's quite easy in the sense that it is both the previous two. So when are two events complementary, what does it mean? They are mutually exclusive and they're also exhaustive. So you will notice what I wrote here. I said, if they're complementary, and is 0 or is 1. So both of them apply. And that gives us a new rule, which I quite like just to call it the not rule. It doesn't really have a name, so just give it some sort of name, that the P of not A, and you will notice that at the bottom, the P of not A is 1 minus the P of A, and the P of A is 1 minus the P of not A. So that is what we get if two events are complementary. We can use that. So let's look at the following examples, and they are now based on mutually exclusive, exhaustive, and complementary. So then you can see how we use those rules. So in this third problem, they say here that two mutually exclusive events. So that is given to us. The two events are mutually exclusive. I always recommend to the learners that if you read that, write down immediately that the P of A and B is equal to 0. Because they will get a mark in the exam for this, because they need to know this, even if they can't maybe continue with the question. But there's something else that is quite important. You will notice now that the P of A was given to us, but the P of B was not quite given to us. The P of not B is given to us. But for our rule, we need the P of B. And that is that not rule that I referred to on this previous page. So if I want the P of A, like you can see in this rule, you say it's 1 minus the P of not A. So we're just going to subtract. So I'm just going to say that the P of B is 1 minus the P of not B, which is 1 minus 0,4, which is 0,6. So now we know what AND is, we know what the P of B is, we know the P of A, so we are ready to find OR. So we're going to say that the P of A or B is equal to the P of A plus the P of B minus the P of A and B. And now when we substitute, we say the P of A was 0,3. The P of B, we calculated that 0,6 minus 0 for the AND. And that gives us a probability of 0,9. I don't think there's a mistake anywhere. Sometimes it's easy to make mistakes when you think the questions are still easy, but everything looks good. Let's move to example 4. Now I say two exhaustive events. So before we carry on reading, that exhaustive events that we see here tells us something. So I just want to point you back again. If two events are exhaustive, OR is 1. Mutually exclusive, AND is 0. Exhaustive, then OR will be 1. So we're going to write that down immediately, that the P of X or Y is equal to 1. You will notice that P of X is given to us, and the AND is also given to us. We also know what OR is. So you will see in this question, we have OR as well as AND. And now the question is to find the P of Y. So basically in that general rule, there are 4 unknowns, the or, the and then the A and the B. And they can ask any one of those 4 given the other ones. So let's just write down our rule again. So we say the P of X or Y is equal to the P of X plus the P of Y minus the P of X and Y. Now the OR is 1, we said already, because they are exhaustive. P of X is given to us as 0,9. P of Y is what we are looking for, so we keep it, minus the AND was given to us as 0,7. Now to manipulate this is pretty straightforward. We just take 0,9 minus 0,7, which is 0,2, take it to the left-hand side, and then we have the P of Y. So we can now say that the P of Y will be 1 minus, and this 0,9 minus 0,7 is 0,2, which gives us then an answer of 0,8 for the P of Y. All right, if I double check this, everything looks good. I think it's all correct. And I'm pretty sure you are still with me on this one. So let's look at the next page. And what these rules that I just did, what I discussed with you, the general rule, mutually exclusive, exhaustive, as well as complementary, that not rule, they are also from grade 10. We also discussed those in grade 10. And then we get to a new rule, which is we do the first time in grade 11, and that is independent events. Now, many people confuse with independent events. The important thing about independent events is that, and you will see I gave that a little bit definition at the top of the page. I said there that 2 events are independent if the probability of the one is not influenced by whether the other happens or not. If 2 events A and B are independent, the following rules apply, or rule apply. So 2 events, they are called independent if the one probability does not influence the other one. So for an example, I think it's one that I've put in the textbook as well. I say, for instance, if I talk about myself, then I say I'm a male and I'm born in May, the month, my birth month. So my one event is male, female. The other event is your month of birth. Here clearly, those 2 events does not influence one another. So if you're male or female, does not affect your month of birth. It can be male or female. So those 2 events are independent. One for dependent events is that if you get up in the morning, and maybe it's not a good example for Cape Town at this point in time, but normally if you look out the window in the morning and you notice that it is overcast, and then the second event is there will be rain later. Now, overcast definitely influence the chance of rain. So overcast and rain, those 2 events are not independent. I still prefer to talk about dependent and not independent. I know some people like to talk about dependent events because not independent is like a double negative. And then people say, but it means, yes, within the English language, yes, not independent will mean dependent, but we don't quite have a definition for dependent. So if I ask someone, What does it mean if two events are dependent? We can't quite answer it. The only way we can say is we can say they are not independent. And that is why I prefer to stick to that, to talk about dependent or not. I always use the example in algebra. We talk about functions and we talk about non-functions. So we have functions and we have others that's not functions. And just to name an example. Now, if the two events are independent, then this rule is true. And the learners must know this rule. It's not on the formula sheet, that the P of A and B is equal to the P of A times the P of B. I'm going to refer back to this rule later when we do tree diagrams, where many people think on a tree diagram, we multiply the probabilities on the branches, and they take this multiplication, then it gives you and it's got nothing to do with this. So ladies and gentlemen, I will say it again when we talk about tree diagrams, and or not independent, mutually exclusive, exhaustive, none of those rules apply within tree diagrams. That's why I always like to do tree diagrams right at the end. It's a sort of almost a separate topic, but more about that later. So this rule and is equal to the product. I say here, if A and B are two independent events, so they told us the two events are independent. So that means the rule is true. They give us the P of A, they give us the P of B, and they ask us for OR. You will notice that to find OR, we need to use the general rule. But to use the general rule, we need AND. But we don't have AND, but we can find it because of the fact that the two events are independent. So we will do that first. So we will say that the P of A and B is equal to the P of A times the P of B. That's my rule for independent events. And that is 0,6 times 0,5, which is 0,3, if I'm correct. I think so. And now they ask us for OR. So now we have AND, we've got the P of A, we've got the P of B. So we've got everything to find OR. So now we say the P of A or B. Ladies and gentlemen, at this time, I'm not going to write down the whole formula just for time constraints here. So, but you know, please recommend your learners that they must write down the formula before they substitute. And then we will substitute the P of A as 0,6 plus the P of B as 0,5 minus the AND as 0,3. And that will give us, I think, 0,8 for that probability if the two events are independent. So that is not a too difficult one. The one that is very popular is this for the next question. I say events A and B are such, P of A is given, P of not B is given, but that you will know from our not rule, we can find the P of B, and OR is given. And now they ask us if two events are independent. So we must now, what we need to do is to check if this rule is true. So we must find and we must find the product separately. And we must see if the two. So we talk about left-hand side and right-hand side. So left-hand side is and, right-hand side is the product. Because the question is, are they independent? Yes or no? So we have the two events. So the first thing I'm going to do is from this P of not B, I'm going to say the P of B is 0,7 because it's 1 minus the 0,3. We also know the OR and we know the P of A. So I'm first of all going to use the general rule. where the P of A or B is equal to the P of A plus the P of B minus the AND. Now, AND is what we are looking for. So I'm going to take the AND to the left-hand side, and then I go 0,5 plus P of B 0,7 minus the OR of 0,8. And then you will notice that our AND will be, I think it's 0,4 for my AND. So we have now the left-hand side of this because we know what the probability of A and B is. Now we need to find the product, the left-hand side. So we can say left-hand side is equal to the P of A times the P of B, which is then 0,5 times 0,7, which is then 0,35. And as you can see, that the left-hand side is not equal to the right-hand side. You can say that is, no, that is a little bit dumb. This was the right-hand side. So let me just change this to the right-hand side. And this one is the left-hand side. And then we can say, therefore, not independent. Because the AND is not equal to the product. They quite like these questions. They can test it in rules. They can test it in Venn diagrams. Also in two-way tables, they like to test this. So it's important that your learners know how to show or determine if two events are independent or not. I hope so far you are still with me. We are making good progress, but we're still on rules, and I maybe need to move a little bit faster. This next example, ladies and gentlemen, I don't want to rush. This is a typical exam question. They quite like this. They say there are two events, X and Y, such that the P of X is given or is given. They ask us to find the P of Y. And now in the first one, they say the events are mutually exclusive. And in the B part, they say X and Y are independent. Now, if you think about it for a moment, mutually exclusive, it's about AND, which is 0. Independent is about AND, which is the product. So you will notice in our given information, in this information, they said nothing about AND. So we can't calculate the P of Y if we don't know what AND is. But they tell us what AND is by giving us this. So it means we can say that the P of X and Y is 0 because actually the P of X or Y is equal to the P of X plus the P of Y minus the AND. Now, the OR is given to us as 0,7. P of X is given as 0,4. P of Y is what we are looking for, minus, and the AND is 0. So if we take this 0,4 to the left, then we can say that the P of Y is then 0,3, 0,7 minus the 0,4. So that is now if two events are mutually exclusive and they want us. So we've done similar ones to like this. The interesting one is the second one is the one when they are independent. Now, when we want to do this particular one, we have that the P of X or Y is equal to the P of X plus the P of Y minus the P of X and Y. So let's just quickly have a look what we have here. The OR was given to us as 0,7. P of X is given to us as 0,4. P of y is our question. We want to find the P of y minus the and. But we don't know what and is, but we can find it. And again, you can discuss it with your learners what they prefer. But you will notice what I did here. I substituted the P of x and y with the P of x times the P of y. And that is the rule for independent events. The alternative is that your learners first calculate the P of x and y separately and then just substitute the answer in. So either way, it is acceptable. So let's move the 0,4 to the left, and that will leave us with 0,3 is equal to the P of y minus, in this bracket, the square brackets, we've got the P of x, which we know, and P of x was given to us as 0,4 times P of y. And now, ladies and gentlemen, you will notice that some of your learners will pick up a problem here. They don't know how to subtract these two. This feels very, very strange, and sometimes some of them get them, but when I did this, many of them, they just couldn't figure it out. What I always tell them is they must remember P of y is my unknown. So we can call it x. So if they don't understand, just quickly write down for them. Let's call P of y x minus 0,4x. And then even you can put a 1 there. And then it's very clear, is 0,6x or 0,6 py. So just to explain that subtraction. Now we divide both sides by 0,6, and you will agree with me that I will get 0,3 over 0,6, which is a half, or we can say 0,5, whatever you prefer. So these two questions are very important for exams, because that is, you will notice they test almost all the rules. They test mutually exclusive, independent, general rule in one question, and that is always ideal for exams. So make sure your learners are comfortable with these questions. All right, so our next topic, Venn diagrams. Now, ladies and gentlemen, I've put this page in. If you don't mind, I will come back to it. I just quickly want to show you something, and then this will make more sense why I gave you all these little drawings. So if we look at this particular question, you will see that two events A and B are such that the P of A and B is 0,08, the P of A and not B is 0,32, P of B is 0,2. Represent this information on a Venn diagram. So this is a two-event Venn diagram. After this one, we're also going to look at the three-event, which is typical grade 11. But if we draw this Venn diagram, you will hopefully notice that we have one big problem. And the problem that we have with this one is this part, the P of A and not B. What is that? Where is it? And that is where your learners will struggle a little bit. So make sure they know how to do this. These are the sort of more difficult Venn diagram questions. If we not only ask for or and, but we ask now, we bring in a not into the picture as well. Now we need to complete this. Now, whenever we do a Venn diagram, the and is first, this part. We first put that one in. And if you don't know it, you must first calculate it. Otherwise, you can't continue with your Venn diagram. Now, in this particular problem, and was given to you is 0,08. So that is what I'm going to put in here, 0,08. Now we have this one, and I will come back to this one. And then we have the P of B. Now the P of B is 0,2. Now that 0,2 refers to the whole of B, but we've got 0,08 already. So to find this one, the B only part, we need to subtract 0,08 from 0,2. So I'm just going to write it down so that you can see exactly what I'm doing. So 0,2 minus 0,08, and that gives us whatever the probability is for that one only, because these two together must be 0,2. So this will be 0,12, I think. But now you will notice that we still don't know what is here. And then we also need to know whatever is outside. But before we can go to outside, we first need to find P only. So I would like to discuss this part with you now, this one. Now I'm going to do a separate little drawing that I don't mess up this one. So just a quick drawing. We're not going to write any information on here. I'm just going to quickly show you how I like to do it. I prefer to use a very straightforward method, and that is to use little ticks. Those of you who've got the textbook, you will see I used it there as well. So when we look at this given part, we have the P of A and not B. The P of A and not B. I want to know where is that on this diagram. So first of all, you look at A. On the diagram, which parts represents A? And you will agree it's this one and that one. Both of them is part of A. Now we need to find not B. Now not B is when I cover B, what is left? And you will agree with me, what is left is this part and outside. That is what not B is. Unfortunately, I can't show you now, but if you put your finger and you cover the B with your finger, you will, when you cover B with your finger, then you will see what is left. So that's sort of the easiest way to do that one. And this was 0, no, I'm now totally messed up here. So P of A is this and that. P of not B is this and outside. There's an and means both. So where is this A and not B? You will agree with me, is this part. That's where the two ticks are. So and is both, or is, if we can, I can ask you the same question, but just change the and to or. And if that is or, your answer will be this one plus that one plus that one. So everyone with a tick, that is where you will find or. This one's got an and is only this part. And that is what we are looking for. And this one is then 0,32. So we've got 0,32, 0,08, and 0,12. We don't know what is outside. So the probability of the sample space, I mentioned that earlier, is always 1. So what we need to do is we need to take 0.32 plus 0.08 plus the 0.12, add them, and subtract from 1. And I think you will agree that if I do that, I will get, where is it, 0.52 from 1, and that will be 0.52. It's 4.8, I think. Just want to make sure that I'm correct. Yeah, I think so. So now our Venn diagram is completed. So we've got our Venn diagram, all the probabilities on all 3 of those little areas. And when I refer to these areas, I'm referring to this and this and this and that one, the 4 parts. And we're now going to answer these questions. So let's look at the first question. They ask for OR. Now, you will notice when you ask your learners how they will do it, they will most probably say we use the general rule, which is quite possible to use. But we have a Venn diagram, so it's much easier. So we're just going to add. So this OR will be 0.32 plus 0.08 plus 0.12, because they all part of OR, everything inside. So the only thing that is not part of OR is this one. So you will agree that answer then 0.52 for the OR. Now you will notice that I've got a funny one again. P of A, sorry, not A and not B. So now there's a not with both as well as an and. So we want to know where the 2 ticks are. So I am going to use now quickly I just want to get some color. Try it in maybe in blue or something. I want to see. So I'm going to use the little ticks. So I first of all want to tick not A. Now, not A is everything outside that A. So I hope you will agree that that will be this part is, no, it's not A, not, I'm jumping the gun a little bit. So not A, we remove both parts of A, and whatever is left is not A. So not A will be this one and outside. So that will be our not A. Now we need to find not B. Now that is when you cover B again. So we're going to cover the whole of B, like I already wanted to do. And then we tick, what do you get? So if you cover B, you will get the 0.32 and you will get the outside. And I hope you agree with me on that one. So the not A, everything except the whole of A. Not B, everything except the whole of B. And there's an and. So that means, you will notice the question is and. So it means we want the 2 ticks. And that is outside. And as you now can see, it's so easy. Once you tick, you can just write down the answer as 0.48. That is the P of not A and not B. Before we look at the independent events, I just want to take you now back to the previous page. And this is a summary of the 6 possibilities. So there are 6 possible questions we can ask. The A and not B, the A or not B. And this shaded part represents what this one stands for. So the not is with B and or. The not is with A, you can see with A and an or. And now the not is with A as well as with B, with A as well as B, and an or. And you will notice this is the one that we just spoke about just now in the previous question. That was the not A and the not B. And the shaded part outside is. I will not recommend that your learners memorize it if they want to, but it's quite risky. I prefer that they just tick those events and they can find it. But this is a nice, these diagrams are quite nice to have with you when they do exercises, and they can get used to it and check. But I will still recommend they use the ticks. I just maybe want to do one of them quickly. And I want to look at this particular one of not A or B. So when I look at not A, it's everything except A. Then I will tick not this one. I will tick that and outside because it is not A. So everything except A. And then B. And B is this one and that one. And you will hopefully agree with me that these three parts that we ticked here, this part as well as this one, let me just point for you, this part, this one, and that one, that is the shaded part. So if we want that probability, we must take this plus that for the answer. So just to explain a little bit more on these sort of more complicated Venn diagrams and they did ask these questions previously in exams. All right, the last one again is if the two events are independent. Now, for independent, we have left-hand side and right-hand side, so it's and as well as the product. So the nice thing now is the P of A and B is given to us as 0,08. So we have the and this is our left-hand side. So now, if we go for the right-hand side, we will say the P of A times the P of B, and the P of A, P of B was given to us, but we calculated the P of A as 0,32 plus 0,08, so that is 0,4. The P of B was given to us as 0,2, so it's 0,4 times 0,2, which hopefully you will agree with me is 0,08. So that means the left-hand side is equal to the right-hand side. So therefore, they are independent. You will notice, remember the previous one we did was on dependent events, and these on independent. So independent, if left-hand side is equal to the right-hand side, if and is equal to the product. We will do another one of these when we discuss the two-way tables. So let's look at the next example. Two independent events. So that means the P of A and B is equal to the P of A times the P of B. So we know that because they are independent. P of A is given, P of B is given, and they ask us for this one. Now, the moment they ask you for the P of a not A or a not B or both with a not, ladies and gentlemen, the best way to do it is with a tree diagram. I didn't say it in the question, but please tell your learners, these questions we can't calculate by means of rules. It's just too complicated. We prefer a Venn diagram so we can tick and we can answer the question. So first of all, we know what the P of A is and what the P of B is. And we know they're independent. So hopefully you agree when I say that the P of A and B is equal to the P of A times the P of B. which is 0,6 times 0,4, which is 0,24. Now we know and. We've got A, we've got B, we've got and. So what else do we need? We can find or with the general rule. That's also possible. But the moment we know and, we can start with our Venn diagram. So let's do the Venn diagram now and see if we need anything else. So this is S. So this is event A, event B. My and is 0,24. P of A is 0,6 minus 0,2 is 0,4. And that will give me, I think, 0,36. Because these two must add up to 0,6, because that is the whole of P. And yes, that is correct. We know what the P of B is. It's 0,4. We need to subtract the 0,24 from the 0,4, and that will be 0. Let me now speak the pen. 0, that will be 1, 6. Yes, correct. I'm happy with that. So now we've got all three, because we calculated and, we can find the other two. And or, if we need or, we can just add these three. But more important for now is we need outside. And how will we get the outside? We need to add all three of them. That is why I mentioned or. And we need to subtract it from 1 so that we can get outside. So it was the A was 0,6, which include this one, plus 0,16. So what we now can do is we can say that the outside will be, maybe I must just put a little arrow so I just explain it. So I will say 1 minus in a bracket 0,6 plus 0,16, which will give us 7,6, which will give us 0,24. I hope I'm correct. Please, if I made a mistake and you pick it up, please correct me. So that is just to find the outside. So now we've got the whole diagram, everything on it. So now we can use this diagram to find that P of not A or B. I'm going to use the ticks again. And I'm going to say it's the P of not A. So we cover A, what is left? This one and outside. That was the not A. The other event is B, and B is this one and that one. And they ask for or. So what we're now going to say is we're going to say the P of, let me just take this out. The P of not A or B, that was the question. I need to add all those areas with a tick. So it's 0,24. 0,24 plus 0,16 plus 0,24 for the outside. And that will give us 0, what is that? 0,4 is that? I think it will be 64 for that probability. And you can see it's quite easy to answer them by means of a Venn diagram. I always recommend that we use a Venn diagram for these ones. So, ladies and gentlemen, we've got one problem left on Venn diagrams. I notice it's just now a few minutes past 4. If it's okay with you, if we can just quickly take a a 5-minute break if you quickly want maybe to get a cup of coffee or just stretch your legs, and I will see you in a few minutes' time.
Okay, while Jurg is just taking a quick break, I just wanted to mention those that didn't see our introduction, that we will have on the 24th of July, we will have another webinar on the counting principle, and that would be for the grade 12 educators. And so we will be sending the link to register out tomorrow, and we will email to every one of you that has registered for this webinar as well. Okay, so yeah, we'll see you in a few minutes. Please don't leave us. Just a couple of minutes and then we're back on.
Rizal, I don't know if you are ready. Ladies and gentlemen, I don't know if you all back, then we can continue. Just waiting for Rizal for a moment.
Yeah, we're good to
Yes.
go. Yeah.
I'm ready.
Okay.
All right, ladies and gentlemen, our last problem on Venn diagrams that I would like to discuss with you are the problems on 3 events. This we don't do in grade 10. We only do 2 events in grade 10. We also do 2 events in grade 11, but we also look at 3 events in grade 11. And that is what I'm going to discuss with you now. Time, try to make a nice drawing for the 3 events. And you will notice this problem is about cell phones, tablets, and laptops. These are the things that our young people, but maybe other people as well, quite like nowadays, that we like the screens. And I thought it will be a nice problem for the learners because they do understand this quite well. Now, when you look at the information given, you will see, yes, one they give you all the numbers on each one of the devices. And that is now cell phones, tablets, laptops. And then they gave us 40 on 2, 50 on those 2, 30 on those, and then 35, and then 30 on all 3. And that is what we are looking for. We are looking for those that's given where all 3 are given to you, because that is the middle, that is the spot. And we always need to start with that intersection of the 3 events. Now, this is not probabilities, these are numbers. Now, you will notice that also given to us is the sample space of 150. Please advise your learners that next to sample space, I quite like in a bracket, just to write that down, the 150, because we will need it when we answer the questions. So that is our sample space, is 150. And now we're going to complete, and we start from the inside and we go out. So what I mean when I say this is we will do this part first, then we go for this, this, and that. Then we go for those, and then we go for outside. And then we've got everything, and then we can answer the questions. So let's start. I'm going to start with the last one. That is the 30. I like to tick them that I know which ones I used already. And that 30 goes in the middle. Now I'm just going to go one up to the 35, tablets and laptops. Now, if you look at tablets and laptops, that is this intersection. And that is 35. But please take note, we've got 30 already. So it means there's 5 there. Then I go to the 50. And the 50 is cell phones and laptops. So it's cell phones and laptops. So it is this intersection is 50. 30 is there already. So you most probably know what I'm going to say. 20 will go there because they must add up to 50. And then for the third one is the 40. And the 40 cell phones and tablets. So it's cell phones and tablets. So it is this intersection is 40. 30 is there already. So that is 10. So now we now know the 3 events. All those represent 2 events. Now we go for 1 event. So we now go for that 125 cell phones. So the 125. Now, if I go for cell phones, I'm referring to this part. So that is 125. Now, 10 plus 30 plus 20 is 60, and that we need to subtract from the 125, and that will give us 65 to the 125. And then we do the same for the 47 tablets. So we have 10 plus 30 is 40, plus 5 is 45. There was 47 tablets. So that leaves us with 2 who own tablets only. And then the last one, the 58 laptops. So when I look at 58 laptops, I say 20 plus 30 is 50, plus 5 is 55, subtract from 58, and we are left with 3. So now we have, and very important that the learners must understand that this is 3 events. This, and that are 2 events. This one, and this one, only 1 event, and outside, no event. So the number outside, which is not given to us, we must calculate it, they don't own any device. How do we get it? We add everything inside, this, plus that, this, and that. We subtract it from 150, and we get the answer of outside, and that is 15 for the outside. And you will notice if we add all of them, we will get the 150 of the sample space. Now, this is the important part, which the learners must get correct, because otherwise their answers can be a real issue. Ladies and gentlemen, you must now excuse, because the questions are now on the following page, and I'm just going to switch going back and forth so that we discuss those questions. So the questions are on this page, number B and C. And I first want to point out something to you. In B, I ask for how many. How many? That means I'm looking for a number. In C, I ask probability. So that means whatever the number is in the numerator, they must divide it by the sample space. But let's start with the B part. You will notice I gave 5 questions on how many. In an exam, they will not get so many, but in a discussion in class, it's ideal because they can see all the different kinds of questions. And that's why I've put quite a number of questions in. The first question is, how many of the teenagers own only cell phones, or we can say cell phones only? Cell phones only, I think you all, if I look at the drawing, is that one. That's cell phones only, because the 10 also own tablets. The 30, the other 2, the 20, laptops. So cell phones only, and it's a number, so we just write it down. So cell phones only, 65. Now in number 2, they say cell phones and laptops, but not tablets. We must exclude the tablets. So we look at cell phones and laptops. Cell phones and laptops, so we talk about this one, cell phones and laptops, but not tablets. So if I look at this one, you notice the 30 include tablets. So our answer is only the 20. So I'm just going to say 20 next to that one. Number 3 is where it becomes interesting. Is exactly one of the 3 devices. They say exactly one device. Now, where do we find one device? 65, one device. They only own cell phones. 2 owns tablets only. 3, laptops only. So we're going to say 65 plus 2 plus 3, because those teenagers owns one device only. So I'm just going to write down 65 plus 2 plus 3, which will give us 70. And think I'm correct? 65 plus 2 plus 3. Yes. Third question. exactly 2 of the 3 devices. So where do we find 2 of 3 devices, or 2 devices only? And you will agree it's the 10, it's the 20, it's also the 5. And we're going to add those 3. 10 plus 20 is 30, plus the 5 is 35. So I'm going to go back and I'm just going to say exactly 2 will be that 35 when I add the 2 devices. I'm just showing you again the 2 devices. That is the 10 plus the 20, because remember the 30, those 30 people own 3 devices. So it's 10 plus 20 plus the 5, which gives us 35. Now for the last question on B, and that is a sort of a different kind of one that you don't always see. I say at least one of the 3 devices. And the difficulty here for the learners is basically the language. They don't quite understand what do we mean by at least one of the 3. Let me just, at least one of the 3. Now, when we say at least one, it means one device, but it can also be 2. It can also be 3. So at least 1 means that is the minimum, but it can be more. But there are only 3. So it's 1 plus 2 plus 3. Now, when I say 1 device plus 2 devices plus 3 devices, then what I'm saying is we must add everything inside, because that is at least 1. Because these represents 1 device, those represents 2 devices, and that one represents 3 devices. When they say at least 1, you include 1, 2, plus 3. Now, the easy way to work it out, we can add all of them, or we can say the sample space of 150, subtract the outside of the 15. And that is a pretty short way to do it. We can just say 150 minus 15, which is then 135. All right, I think everyone is happy so far. I hope so. When we go to the C part, these are the probability questions. Now, I always recommend to the learners, when you see probability, you look at the first question, they say none of the 3 devices. Before you look at the diagram, just immediately write down your denominator of 150 so that you don't forget. This one will also have a denominator of 150 in this one as well, because they ask probability. And you remember that first formula that we did is the P of E is the N of E over the N of S. And this is the N of S. Now we need to find the N of E, the N of the event. And the event is none of the 3. Now, none of the 3, I think you're all comfortable. It's 15. So that is none of the 3. So that means we put the 15 above the line. And of course, we can still simplify that. If we look at the next question, I say at least 2 of the 3. Remember, in the previous one, it was at least 1 of the 3. Now it is at least 2 of the 3. Now, 2 devices, now the minimum. These are the 2 devices. They now the minimum, but it can be more. So the 3 also included. So the 65, the 2, the 3, and the 15 are not part of it. So it's minimum of 2 or more, at least 2. So it is 10 plus 20 is 30, plus 30 is 60, plus 5 is 65 over our sample space of 150. That's 65. And that we can still simplify as well. Okay, the last one is a tricky one. I haven't seen one like this in any exam paper. Maybe I just miss it. But just for the fun, this one is not at least, this one is at most. So now a maximum is given, but it can be less. So let's look at the diagram. They say at most 2. So the maximum number is 2, but it can be less. So I hope you agree that 65, 2, and 3 are excluded because they are, no, what was this? Sorry. Let me just go back to my question. I think at most 2. Yeah, at most 2. So what is excluded is not the 65, and that is the 30 because that is 3. It is a maximum of 2, but it can be 1 as well. So we're going to take 10 plus 20 plus 5 plus 65 plus 2 plus 30. But now the big question, what about the 15? Yes, it's also part of it because the maximum 2 devices. So we're going to add 2 devices, 1 device, 0 device. So it's everything except for 30. So you agree again, to work it out, we can subtract the 30 from the 150, and that will give us this numerator, and that will be 120, which is quite easy to simplify as well. All right, ladies and gentlemen, that is about Venn diagrams. So there is another question. I decided to put this one in. You notice I didn't put in any space. I left this one for you guys, that you do it with your learners. I just want to point out one thing, and that is that we have the given information here, like in the previous one, but something else that is a little bit different to the previous one is, they say in the first one, when they ask us to draw the Venn diagram, they say, let the number of learners use all 3 modes of transport be X. So that very middle of the 3 events, and if I can go back to this one, it's this middle. That will be X now. It was not given as a number. So now we start with that middle, call it X, and then you find all the others in terms of X. And then you will see in B, they ask you to solve X. So you add everything, put it equal to the sample space, which was given to us as 100 grade 11 learners. And you can find your X, and then it means you can answer those few questions at number C. So it's a little bit of algebra involved here with the X, and sometimes the learners get confused, but not too bad. So I realize we're not going to have most probably enough time because we still have 2 topics left in this half an hour. So ladies and gentlemen, 2-way contingency tables. I have 2 examples here as well. Let's discuss the first one because I would like to spend a little bit more time on the tree diagrams. The 2-way tables are the easiest part of the probability. It's really straightforward. Really not many issues with these. So when we look at this one, it's about male and female. It's about pass and fail mathematics. It's 150 grade 11 learners. You will see there's the 150. That is your sample space. They gave it to us here, but you can also get it there. These are the total number that pass, total number that fail, the total number of males, total number of females, and the sample space. Now, the first question, they say, if a learner is randomly selected, what is the probability? So that means we must have the sample space, that the learner is male. So how many males are there? And we can look at our table, and how many males are there is 70. So we will say 70 over the 150. It's only a 1 event, very straightforward. We just read it from the diagram over the sample space. Second question, what is the probability that the learner passes? So what is the total number of pass? Because they didn't refer to male or female. It's only about pass. Doesn't matter what the gender is. So it's 135, 135 over 150. It's now that one that I used. Now I ask for two events, male and pass. So I go male and I go pass. So if you look at male, you look at pass, there's 63. So that is where both of those events happen, male and pass. And that is over the 150. So I write that down as male and pass. Let me just see. Yeah, male and pass is the 63 over 150. In the last one is female or pass. So I want you to take notice that this one is a or. And you must be very careful how to answer this. I want to be very honest. The easiest way to do it is by means of the general rule, to say the P of female or pass is equal to the P of female plus the P of pass minus the P of female and pass. And you agree the female and pass and pass and male, female, we can read all from the diagram. So that is the one way. My experience, majority of learners prefer it because they're now used to it. If you don't mind, I would like to show you something else, but please keep this in mind that you can use the general rule for this one. But I want to show you on the diagram how you can find it as well. Now, when we look at the diagram and I look at female, which ones represent females? And do you agree with me? Those two represent females. The number who passed, the number who failed. Now we talk about pass. Which ones represent pass? And now it's about male and female because it's about pass and it's those two. Now, if you must now use your imagination here, but I hope you can see a tree diagram. There's my one event, and let me just point it out. There's one event, and there's the other event. They're not just, we used to, like they are sort of like next to one another. The one is like this, and the other one is now like that. Now, do you notice the 72 is in both? So that is and. So that is female and pass. Female and pass is 72. But we don't want and, we want or. How do I find or? It is 63 plus 72 plus the 80. We add the 3. You will remember from our Venn diagrams that we spoke about earlier. I'm just going to do this. The or is this plus that plus that. That will give you or. And I hope you can see it there. So if I just write this answer down, your denominator will be 150. What is your numerator? It is the 63 plus the 72 plus 8, which will now be 150, and that will give us 81. Is it 143? I think so. I think it's 143. Female or pass. 143 over 150. And then the next one is what I mentioned earlier. We've done it twice already, and that is if these two events, male, pass, if they are independent. So we're going to do left-hand side and right-hand side. So I say my left-hand side is the probability of male and pass. I'm not going to use only P because I've got a P already, which means probability. And when I look at male and pass, you will agree that we've done it already in number 3, male and pass. And that was the 63 over the 150. my male and pass. Now, this we now need to take to a decimal and round it off, excuse me, to 2 decimals. And I've got 0.42. That is now the left-hand side. That is the and, male and pass. The right-hand side is the probability of male times the probability of pass. So we look for the probability of male. That was the very first answer. Male was 70 over 150 times by pass. We've done that one already. And that was the 135 over the 150. And we now want to see what is that answer in decimals so that we can compare the two answers. Now, before we find that answer, you can already just use your gut feel and say, do you think these two events will be independent or not? Does the fact that the grade 11s fail mathematics or pass mathematics, is that linked to gender? And I don't think so. So I pretty much think these two events are independent because I don't think gender influence pass or fail mathematics. So let's just double check, but I guess we're going to get 0.42. So I will say, I just want to quickly calculate it. And indeed, I just wanted to double check that I've got everything correct, and that indeed is 0.42. So now we say left-hand side is equal to right-hand side. So therefore, these events are independent. All right, I think we've done a couple of those, and I don't think you have a problem with that anymore. So I have another question on two-way tables, which is also a very interesting one. The first question, I always say, the only reason why a question like this will be in an exam, and they did ask it before in the matric final, is to make sure no one gets 0. They must find A, B, C, D, and E. A, B, C, D, and E. Now it's quite easy. 10 minus 1 gives you 9 because you must add the 2 to get that. And once you got that one, you add those 2 to get this one. Once you have these two, you have 100, 200. So this one will be 300, and you can complete the table. It's just addition and subtraction. And the sample space is 300. They said it here. And then they ask 3 questions, and then they ask about if they are independent or not. If you think about this, colorblind and not colorblind, male and female, these events are not independent because gender plays a part in colorblindness. More males are colorblind than females. And a matter of fact, it's way more. It's basically for every 1 female who's born colorblind, there's around about 4 males born colorblind. So it's just to give an example on 2 events that's not independent. And this one, these 2 events, independent. All right. I want to move to our last topic for today, and that is tree diagrams. These first 2 questions, ladies and gentlemen, I'm going to do them together. They're pretty easy. The only reason why I have them is to illustrate. Now, I said before, the rules are not applicable on tree diagrams. This topic of tree diagrams is the introduction to conditional probability. We don't do conditional probability at school. That at tertiary we do that, but we only do the introduction, and that is tree diagrams. So this is about 6 red balls, 4 blue balls. You will notice the two examples are the same. 6 red, 4 blue. The difference is with the one, the drawing is with replacement, this one without replacement. So I'm just quickly going to draw this. They say to us that there are 6 red balls, so we've got red and blue. Here we have the red and blue as well. And we've got 6 red balls and four blue balls. You agree there are 10 balls in the bag. And they say a ball is chosen and the color is recorded and the ball is placed back. A ball is then chosen again and the color is recorded. What is the probability of choosing 2 balls of different colors? So this is my first drawing. And then I'm also going to have a second drawing, red and blue. And this will be red and blue. Now we're going to put our probabilities on these branches. So probability to get red on the first draw is how many red? 6. How many balls? And that is 6 over 10. We can just put the common fractions down. They can put decimals also if they prefer. And for blue will be 4 over 10. What is at most important, ladies and gentlemen, is what your learners must always check. This plus this must always be 1. If it's not 1, it's a principal error. Now we go for the second draw. Now take note, drawing without replacement. So I took the 1 ball, but I didn't put it back. So you agree, if the first one, so this is where that whole conditional comes in. On condition that the first ball was red, what is the probability the second ball is red? So we now say, we use this condition that the first one was red. So you will agree with me, there's 1 lesser red ball, but 1 lesser ball in the bag. So it's now 5 over 9. And for a blue, it's still 4 over 9. And again, you notice this plus that equals 1. So in the problems we're going to do after this one, they sometimes only give you one of this probability. And then you must be able to write this down because they must add up to 1. Do the other branch, blue. 4 over 10 for the first draw. What is the probability the second ball is red? So that means now all the red balls are still there, but there's 1 ball lesser in the bag, so it's 6 over 9. I just noticed I mixed the 2 questions. This one is with replacement. I did it without. Okay. I'm just going to swap them for now, that we just, otherwise we're going to lose time. Sorry for that. I'm a little bit now, rush a little bit, and then of course we make mistakes. What about the second ball is blue? So it's 1 lesser blue, so it's 3 over 9. 5 over 9, 4 over 9. And you will see this is now without replacement. So we select a ball, but we keep it. We don't put it back. Then we select another one. Before we answer the question, I just quickly want to do the branches of this one as well. And that is red, blue, red, blue. And this is now with replacement. So the 6 over 10 will be the same as the 4 over 10. But the first ball was a red one. I took out that ball. I see it's red, but I put it back. So what is the probability the second one will be red? The probability stays the same, 6 over 10, because there's still 6 red. And the blue, 4 over 10. And then when you look at the blue part, we replace it. So that is still 6 over 10. And for blue is still 4 over 10. So what I was trying to show within these 2 questions, when it's without replacement, your probabilities decrease with your drawing. I don't know exactly, but if you understand what I'm trying to say. But if you replace, your probabilities stays the same. Now, you will agree with me, if you look at these two problems, the first one is most probably the more important one, because that is where probabilities change. When there is replacement, when we do replace, probability stays the same, so the question is quite much easier. Now, let's just finish this question. The important thing about tree diagrams is you must write down your outcomes. But please tell your learners, I like just to draw a line that they don't look too messy. So I say the first outcome is red, 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 blue, blue, red, and blue, blue. Now we look at our question. What is the probability of choosing two balls of different colors? Now, same color, different color, same color. So I want both of those two, and I'm going to add the two answers. So I'm going to say now my probability of red, blue, plus the probability of blue, red. You will notice that I just write it down. Blue, red, red, blue. I don't put an and in between. One can do it, but that and is only the language and. It's not the and which is intersection. So that is why I prefer not to write down and between the two, because otherwise it may confuse people what I was trying to say here. So let's quickly find the answer of this one. How do I find the probability of red and blue? So we will go 6/10 times 5/9 plus, and then we go for blue-red, which is 4/10 times, and red is 6/9. And this is just multiplication, which is quite easy. It's 30/90 plus 24/90. And we've got a common denominator, and that is then 54/90. And that is just for that particular one. This one also have a question, so we can also write down our outcomes quickly. Red and blue, blue, red, and blue, blue. Now the question is, we want the same color. And same color is red, red, and blue, blue. So we say the probability of red, red, plus probability of blue, blue. We multiply the red and the red, which is then 6/10 times 6/10, plus, and then blue, blue is the 4/10 times the 4/10. And these are quite easy to multiply. And then we can just get the answer. What is that? 52, I think, over 100. So, ladies and gentlemen, these are not exam questions. These are just to explain the difference between replacement and no replacement. I want to get to the next question. This question is not from the textbook. I've put it in this, and I can't claim this question, so that's why I say it's not in the textbook. This one is from an old matric paper, quite a number of years ago. It was quite a beautiful question, and therefore I thought we must quickly discuss this question because it's really interesting. So we have 20 boys and 15 girls in a class. The teacher chooses individual learners at random to deliver a speech. What is the probability that the first learner chosen is a boy? So that's a very straightforward one. How many boys? How many learners? So we say it is 20 boys and over 35 learners. That's the sample space. So 20/35 is the probability that if a learner is chosen, that it will be a boy. Now they say, draw a tree diagram and represent the situation that the teacher chooses 3 learners, one after the other. So here are 3 events. The previous 2 problems, there were only 2 events. They can test up to 3, but not more. So we're going to draw this tree diagram. We need some space because it's going to be a big one. So we've got boys and girls. On the second row, boy, girl. And then we have a third row, boy, girl. Difficult to fit them all in, boy and girl. And then this one also have a boy and a girl. Oh, this looks really ugly. I just want to try again and just make the top ones a little bit smaller. So it's boy, girl. That's better. All right, let's put the probabilities on. They say to us that probability for a boy is 20 over 35. Probability for a girl is 15 over 35. Now the question is, this is the first draw. 20 over 35, it will be a boy. 15 over 35, it will be a girl. What about the second draw? Now the question is there replacement or not? So the first one, if it was a boy, on condition it was a boy, you will all agree he will not be part of the second selection. He's still in the class, but he's not part of that second selection. So this is a no replacement example. So that means the probabilities will change. So the second boy will be 19 over 34. The girls are still 15 over 34. And you will see if you add those two fractions, you get 1. If you add these first two, you also get 1. So now, if the first one was a girl, for a boy, there's still 20 over 35. And for a girl, the first girl already chosen. So now we have 14 over 34, not 35, but 34. And they add up to 1. Now we go for the third row. First one was a boy, second one a boy, third one a boy. So that means it's 18 over 33. And the girls, no girls yet. So it's still the 15 over 33. And if you add that, you will see you will get 1. When we do boy, girl, 1 of each. So that means 19 over 33. And for the girls, 14 over 33. Then it's a girl, boy. So it's similar to the previous one. It's 1 of each. So for a second boy will be 19 over 33. And for a girl, 14 over 33. Now we've got 2 girls, then a boy. So still all the boys are there, 20 over 33. 2 girls already chosen, so that means 13 over 33. Now we're going to write down the outcomes of boy, 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 and then boy, boy, girl. And then we have boy, girl, boy, and we have boy, girl, girl, and we have girl, boy, boy, girl, boy, girl, and we've got girl, girl, boy, and then we have 3 girls. So there are all the outcomes. You will notice in the question they specified that they said, indicate on your diagram all possible outcomes. And that is what they are looking for. In the finals, they want to see that. So now we're going to answer this question. These 3 questions waiting for us. First one, calculate the probability that a boy, then a girl, and then another boy is chosen. So what I'm looking for is the probability of boy, girl, boy. And you will see the boy, girl, boy is that one. Right over there. That is the boy, girl, boy. So we're going to multiply those 3 branches. The first one is 20 over 35 times 19. No, it's girl now, not boy. I want another boy. So it's now, for the girl, is 15 over 34. And then another boy is then 19/33. And those three, we just multiply, and we get quite a vicious answer of 190/1309, if I'm correct. You can just check on that. So this was a specific one they ask us in that order, so you can't change the order. For examples, they sometimes ask, what is the probability that 2 boys and 1 girl was chosen? So now they don't specify an order. So you must now look, we want 2 boys and a girl. And as you can see, this one is 2 boys and a girl as well as that one. I don't think there's another one, but in terms of 2 boys and a girl, then we need to calculate both of them and add the answers. But in this particular case, that was not what they asked us here. All right, the second one, calculate the probability that all 3 learners chosen are girls. Quite easy. It's the probability of girl, girl, girl. So we look at the 3 girls. This one, and that one. And that's what we're going to multiply. And that is 15/35 times 14/34 times 13/33. And if we multiply that, our answer 13/187. That is the probability that 3 girls will be chosen. The interesting question is the last one. What is the probability that at least one of the learners chosen is a boy? We want at least 1 boy. So which ones here represents at least 1 boy? There are 3 boys. There are 2 boys. There are 2 boys. There's 1 boy. There are 2 boys. There's 1 boy. There's 1 boy. You agree? All of those that I marked in blue now got at least 1 boy. And all of the marks, there it is. So all of them got at least 1 boy. So it means then we must calculate this one, this one, this one, this one, exactly 7 of them, and add them. And you agree that is a lot of work, but there is an easier way to do it. What is it that we don't want? We don't want girl, girl, girl. Now, all these outcomes, all 8 of these, add up to 1. So for this one, we can straightforward say it is 1 minus the probability of girl, girl, girl. Because if I remove this girl, girl, girl from it, you agree the other 7 represents at least 1 boy. And we already calculated the girl, girl, girl. So we say 1 minus 13/187. And that gives us 174/187. So this a pretty good example, exam kind of question where it is not these events, sorry, I just couldn't get the word. These events are let me think carefully. There are no replacement. So this is not a physical replacement. It means that once the first learner was chosen, he's down, but he can't be selected for this as the second person because he's already finished his speech. So this example represents exactly this, that there are no replacement here. I want to finish off with the last one, ladies and gentlemen, if you allow. It's now 5 o'clock, but it will be quick. I will try. And this is one, I just call it conditional outcomes. So Lindiwe either walks to school or she takes the bus. If it rains, there's a 30% chance that she will walk. If it doesn't rain, there's a 90% chance that she will walk. According to the weather forecast, there's a 40% chance that it will rain tomorrow. What is the probability that Lindiwe will walk to school? Learners do find them complicated, these kinds of questions. The reason why I call them conditional outcomes are that the one is on condition of the other one, and we need to decide which one is first. You see, these questions are not about replacement or not. So if I draw my first branches here, you will notice there's a couple of things. It's about walking to school or take the bus. And it is about it rain or it doesn't rain. The question is, what is first? If we say walk and bus is first, then it means she first decide I'm going to walk and then she check the weather. And you will agree with me that doesn't make sense. She first look at the weather, then she decides if I will walk to school or take the bus. So the first event here will be rain. I'm just going to call it no rain, NR for no rain. And then if it rains, she can take the bus or she can walk to school. If there's no rain, she may take the bus or she can walk to school. Then I write down my outcomes: rain and bus, rain and walk, no rain, bus, and no rain, walk. And now we want to answer. Now they ask, oh, we first need to put the probabilities in. What is the chance it will rain? And they gave it to us. They say to us here, there's a 40% chance that it will rain. So rain, 40%, which is 0.4. You will see for no rain was not given. That is 0.6 because they add up to 1. Now we look at the next one. This one is, if it rains, let me just remove these little ones. If it rains, there's a 30% chance that she will walk. So if it rains, 30% chance she will, walk, not bus, walk. And that is then 0.3. And this will be 0.7. And then the last one is, where is it? The 90%. If it doesn't rain, you see, that's the no rain. There's a 90% chance that she will walk. So walk, no rain, 0.9, and that one 0.1. And there we have the probabilities. So let's answer the question. What is the probability she will walk to school? So I'm only interested in walk. I'm not interested in the weather. So over here, she will walk. Over here, she will also walk. So she walks sometimes when it rains and sometimes when it's dry. So we need to do both and we need to add the answers. So I would say the probability of rain walk plus probability of no rain and walk, and I multiply those two branches, 0.4 times 0.3, plus no rain, 0 times walk is 0.9, and you will agree this will give us 0.12. 6 times 9 is 54, 0.54, which will give us 0.66. Please remember what I said in the beginning. If it's given in percentages, you give the answer back, and the chance is 66% that she will walk to school irrespective of the weather. So, ladies and gentlemen, it was fast, but I hope you managed to keep up with me. But all these problems are examples in the textbook. So if you don't have the new grade 11 textbook, please try to get one. And all these solutions you will find in the textbook as well. From my side, I want to wish you a great afternoon and evening. And for those from the Western Cape, all of the best for the hectic weather that you experience down in Cape Town. So have a wonderful evening. Thank you so much. Bye-bye.
Thank you, Jurg. We appreciate the time that you took out of your busy schedule to do this workshop, webinar for us. We really appreciate it. And as I said earlier, please be on the lookout for the link to register for the Counting Principle webinar, which will take place on the 24th of July, and that will be for the grade 12 teachers. And we'll send out the link to each and every one of you that has registered. Thank you so much for joining in, and we hope to see you soon. Stay warm, stay safe, and yeah, have a good evening. Thank you.